Welcome to Chapter 13, the binomial distribution. The binomial distribution, probability distribution, is a discrete probability distribution. Now, we've been dealing with continuous probability distributions when we were working with the normal distribution, but we're back to looking at a very special discrete probability distribution. Now, this binomial probability distribution describes probabilities for experiments that have only two mutually exclusive outcomes. The experiment, again, has only two outcomes. One is going to be called a success, the other is a failure. Now, the word success does not necessarily mean something that's good, it's just what we're looking for in the problem. So, for example, if we're looking at a cobra strike on an animal, a success that we could be studying would be that the animal dies. Now, the failure in this would be that the animal does not die. Now, the definition of a probability distribution. We're going to look at four characteristics that a binomial distribution or binomial experiment has to have. The experiment is going to be performed a fixed number of times. We're going to call this n. Each of these times is called a trial. So there will be a fixed number of trials that we're going to denote by the letter n. Now, these n trials have to be independent. That is, outcomes of one trial will not affect the outcomes of another trial. The third thing that a binomial experiment has to have is that there are only two possible outcomes. We call it either a success or a failure. And the fourth thing that a binomial experiment must have is that the probability of a success is the same for each trial in the particular experiment that we're doing. If all four of these criteria are met, we're looking at a binomial experiment, and our random variable, whatever it is that we're taking measurements on, would have the binomial distribution, probability distribution. So let's look at some notation for a binomial experiment. The number of trials, as I said, will be represented by the letter n, small n. The probability of a success in any single trial will be represented by the letter p. The total number of successes in n trials is represented by the random variable x. So x is called a binomial random variable. Because there cannot be a negative number of successes, that makes no sense, and because there can't be any more than how many trials you have, so there can't be any more than n successes, the values that our binomial random variable can take on will be numbers between 0 and n. 0 meaning there were no successes, all the way to n, that you had a success on each trial. The probability distribution of a binomial random variable is called the binomial distribution. So we're going to take a look at a couple of examples and see whether or not they're binomial. So here it says a shipment of 100 televisions. How many are defective? Now, somehow we know that the probability of a television coming from this particular plant, let's say, of it being defective has a 0.08 chance. So its probability is 0.08 of being defective. This would be considered a binomial. Let's make sure that all four criteria are met. Number one, is there a fixed number of trials? Yes, because there's a fixed number of televisions. Looking at the televisions to see whether it's defective or not is the trial. So we have a fixed number of trials. There can only be two outcomes. Either it's defective or it's not defective, where success is being defective. Number three, are the trials independent? Well, if one television is defective does not affect whether another one is. So we do have independence. And the probability of a success is the same. So there's a fixed number of trials. The trials are independent. Each trial only has two possible outcomes, and the probability of a success is the same for each trial. The four conditions are met. X being the number of defective television sets in a shipment of 100, that random variable x is binomial. So it's binomial, and the way we would write that up would be like this. We would say that, so a shorthand way to write that the random variable x is binomial is we say x is binomial, and in parentheses, the parameters for a binomial is n and p, so we see 100, which is n, and the probability of the success is 0.08. That's how we would write up Just like with the normal, we had x would be normally distributed where we give mu and sigma. For binomial, the parameters are n and p, the number of trials, and p, the probability of a success in any one of the trials. Because remember, the probability of success has to be the same for each trial. Let's look at number 2. A new procedure for treating breast cancer is used on 25 patients. How many patients are cured? The procedure has a probability of 0.76 to cure patients. Now, is this binomial? Well, let's check it out. Is there a fixed number of trials? Yes, we're looking at only 25 patients. Are the trials independent? Yes, whether one person is cured does not affect whether another one is. Each trial only has 2 possible outcomes, yeah, because either you're cured or you're not cured. And 4, the probability of a success is the same for each trial, and sure it is. This treatment has a probability of 0.76 to cure a patient. So my n, the number of trials, is 25. The probability of a success is 0.76. So we would say that x is the number of patients cured out of 25, and therefore x is binomial. It's a binomial random variable with n being 25 and p being 0.76. So the shorthand way we would write this would be. So here we have x is binomial with the parameters 25 trials, that's the n, and the p, probability of a success, is that a patient is cured is 0.76. So the binomial experiment, fixed number of trials, only 2 outcomes for each trial. The trials are independent, and the probability of a success is the same for each trial. Now, what we want to do, there's a particular little x, the count of successes in a binomial setting. So x would be capital X. That random variable would have a binomial distribution with the parameters n and p. And we've already said what all these things, what n is the number of trials, p is the probability of a success, and that the random variable can only take on values between 0 and n. So there's our shorthand method for writing how our random variable is. X is binomial with n and p. Now, how do we find and work with these probabilities? So what's the probability that our binomial will take on particular values or value? Well, how we would write it up is we'd say the probability of x successes out of the n observations, and the shorthand way would say the probability that x equal some value. Or we could actually even have the probability that x is less than a particular value, or the probability that x is greater than or equal to, or less than or equal to. Now, how do we calculate these? Well, you could use the binomial formula. Pretty hairy-looking formula. And there can be some rounding error with that, so you have to be really careful when you use the formula. There are binomial tables. That's another way to find these probabilities. Or we could use statistical software packages. And, of course, we use Minitab, and that's how we're going to be calculating probabilities for the binomial. We're going to be using what's called the cumulative distribution function for the binomial. That's what you'll be given on tests, and that's how I would like you to do your post-test, your homework, and on the quiz on StatPortal, that's how we're going to be giving you these probabilities. You're going to have to work through the CDF. So please become familiar with that, and we're going to learn about that in the next installment of Chapter 13. So in Minitab, we can do things with what's called a probabilities density function, and that's one way. This is called the PDF command in Minitab, but you're going to see the CDFs, and that's what you see here next. It's where you look at the value and everything less than it. So it's very similar to how you calculated your normal distribution, except now we're in a discrete distribution where at a particular value there is probability. So you just have to be careful of the wording of our problems. So as I said, in our next installment of Chapter 13, we're going to be going over how to actually work and find probabilities using Minitab and the CDF command and its output in Minitab.